Okay, so in this video I want to look at applying the Cartesian formula for the area of a triangle. It's in your formula and tables booklets up in your coordinate geometry page 18 I think, and it says the Cartesian formula says this, that the area of a triangle can be calculated by taking half of the absolute value of the difference between x1, y2 and x2, y1. Okay? Key detail is this, of course, as long as one of the points, one of the vertices, I should say, as long as 0, 0 is the third vertex. That's really important. So, you know, if 0, 0, x1, y1 and x2, y2 are the vertices of a triangle, then the area of that triangle can be written as 1/2 of the absolute value of x1, y2 minus x2, y1. So really important. This is the thing that people forget. 0, 0 has to be one of the coordinates, one of the vertices of the triangle for this formula to work. So if we look at this example down here, we have one vertex of the triangle at 0, 0. That means the formula will work here. The other 2 points can be just seen from the graph. C is the point 1, 4. B is the point 4, 2. Okay, so what we have, x1, y1 and x2, y2. It doesn't really matter which you call which. What really matters is that 0, 0 is in this. So B is, this will be my first point, and this will be my second point. So x1, 4, y1, 2, x2, 1, y2, 4. So since 0, 0 is one of the vertices, I can say that the area is equal to, in fact, let me write that out. It's probably a good habit to write out. I'm going to say 0, 0 is a vertex. That's part of the condition of this. And therefore, the area can be written as half of the absolute value of x1, y2. x1 is x1 is 4, y2 is 4. So 4 times 4. Minus x2, y1. x2 is 1, y1 is 2, so it's 1 times 2. And it's really that simple. So 1/2 of 16 subtract 2, which works out as 1/2 of the absolute value of 14. Remember, the absolute value of 14 is just 14. Absolute value is the distance from the origin, or the distance from 0. So 14 is 14 units from 0. Half of 14 is just going to be 7 units squared. So the area of this triangle is going to be 7 units squared. Okay? The area of the triangle is 7 units squared. The formula works because 0, 0 is a vertex. Let me look at a triangle where the formula doesn't work and see what we can do with it. So this formula will not work here, and you've got to ask yourself why not. Well, it doesn't work here because 0, 0 is not one of the vertices. So we have a problem here. This is a difficult problem. However, one thing I should note, and if I just open up a GeoGebra file here, I should know that I can kind of take a triangle and move it around the plane without actually changing its area. So I can move it in any direction I want without stretching it in any way. And if I just took this triangle and moved it down here to the left, diagonally, down and left, well, we would now have a point at the origin. So what I do is something called translating. I take each of these points and I move it in that way. Now I'm going to break that down into 2 movements. That's going to be a movement to the left and then a movement downwards. So what's going to happen is my x coordinates are all going to decrease by 1 when I move to the left, and my y coordinates are all going to decrease by 1 when I move downwards. Okay, so let's have a look. So at the moment I have 3 points, A, B, and C. And A has coordinate 1, 1. B has coordinates 5, 3. And C has coordinates 2, 5. And what I'm going to do is translate each of these in such a way that I'm moving 1 unit to the left and then 1 unit downwards. Okay, 1 unit to the left and 1 unit downwards. 1 unit to the left and 1 unit downwards. Let me just put that in again. So I'm going to take all the points and I'm going to move them 1 unit to the left and 1 unit down. 1 unit to the left, 1 unit down. 1 unit to the left and 1 unit down. And you can see those new points. You can see those new points and put them in there. There's C will be there, or the image of C, the image of A will be there, the image of B. We translate them. What we did was, by moving them 1 unit to the left, we reduce the x coordinate by 1. And by moving them down, we reduce the y coordinate by 1. And this is called a translation. 1 unit left, 1 unit down. And I'm going to investigate what I get with each of these. Decrease the x by 1. And what I get is A dash, the image of A. 1 unit left, 1 unit down. Decrease the x by 1. Decrease the y by 1. That'll go to 0, 0. B dash will be the image of B. 1 unit to the left, 1 unit down. Decrease the 5 by 1. Decrease the 3 by 1. 2, 5. The image of that point. Decrease the x coordinate by 1. Decrease the y coordinate by 1. Is 1, 4. And again, you can see those things there. There's a dash, 0, 0. B dash is at 4, 2. C dash over here is at 1, 4. Okay? And if I draw that new triangle in, I draw in the new triangle here as best as I can. And it's green here. So from this is my triangle, and we're saying that this triangle will have exactly the same area as the original triangle. So what I'm saying is the area of triangle ABC will be exactly equal to the area of this image triangle. Triangle A dash, B dash, C dash. In geometry, A dash means the image of A, B dash means the image of B, C dash means the image of B. So now I just have to find the area of that triangle, but just if you look back at the last example I did, that was precisely the triangle I had used there. So I already know that the area of that triangle is 7 units squared. So this is my Cartesian formula for finding the area of a triangle. So it's a fourth formula. We have to decide, which is best in our problem solving. So practice, lots of examples, and you'll get better and better at that stuff.